something happened the other day when I was strolling in a garden and suddenly, my oh my, an apple fell down from the tree. And I wondered, why did the apple fall downwards? I wonder if other objects fall downwards too. No, I'm not gonna try it with my own phone. Well, I have a green ball here and let's investigate using this green ball. Okay, are you ready? Let's see. First, I drop it from the front. It fell downwards. Next, I tried dropping it from my right. Yes, it fell downwards too. What about from my left? Yes, it still fell downwards. Next, let me try tossing it upwards. Ooh, it still fell downwards. Lastly, I tried throwing it backwards. Yes, it still fell down. I wonder why it still goes downwards. Why, oh why? Aha! I got it! Well, it's because of gravity. Yes, what is gravity? Gravity is a force that pulls objects towards the center of the earth. Oh my god, I'm a genius!
Didik TV KPM.
Yeah, I'm the king of the world. Hello everyone, you're now watching Level 2, also known as Tahap 2 on DLP KPM together with me, Sean Stephen, as your host. Now before we begin, I'd like to remind you to always follow the SOPs in place in our battle against COVID-19 to flatten the curve. Obviously, to wash your hands as often as possible using water and soap. Use hand sanitizer to ensure that your hands are also clean, and wear your face mask when you are not at home. And for today, as you saw in the video earlier, there is a very interesting topic that we'll be learning today. But first, let's have a look at the teacher's profile. And there you have it. Together with us today, we have Teacher Nina. Hello, teacher.
Hello, Sean.
How are you doing today?
I'm fine, Alhamdulillah.
Yes, and before we continue, could you kindly introduce yourself to our friends who's watching at home right now?
Okay, hi, hello everyone. My name is Teacher Nina. I'm a science teacher from Sekolah Kebangsaan Putrajaya Persin 181.
All right, and before we continue, obviously I would like to ask you to also follow the SOP or practice the SOP. I have a hand sanitizer or a bottle of hand sanitizer. Again, we always have to ensure we do that whether we're at home or even in public places.
Yes.
But more importantly, I would like to ask you, based on the video that we saw earlier, what's that got to do with our lesson today?
For today, we are going to learn 3 things. Gravity, rotation, and revolution of the Earth.
Okay.
So in the video, in the beginning,
Yeah.
we saw that the meaning of gravity. What is gravity actually?
All right.
So Sean, what is gravity?
Let me try and answer that. So gravity is if I were to let go of something, it will fall towards the ground. So I would say it's a type of force.
Yes, it's
that
a force.
pulls objects towards the ground, or because we're on Earth, so maybe towards the center of the Earth, something like that.
Yes, you are right,
Yay!
Sean. Woohoo! Wow. Start off the show and Sean already got 1 star.
Yes,
Yeah.
1 star for me.
Yes, what Sean told us just now is absolutely right. Gravity is actually a force that pulls objects towards the center of the Earth.
Okay, yeah.
And then, so why do we need to learn about gravity? What is the importance?
All right.
Or what are the effects of gravity, Sean? What do you think?
What are the effects is a very good question. Maybe you could help me answer that.
Okay, don't worry. Okay,
Yeah.
so we have a globe right here. Just
Yep.
imagine we are on Earth right now. Of course, we are. So we have some figurines here. Can you
Okay.
help and put the figurines? Okay,
I can just stick them around?
Yes.
Okay, so I'll just move
I'll
here.
have this Donkey Kong here, maybe. Okay.
Maybe I'll have Mr. Froggy swimming in the North Pacific Ocean.
Okay. And this choo-choo train will be somewhere here in the equator in Colombia.
Okay, I got a superhero figurine. Maybe I'll put him at the bottom here at the South Pacific
Will
Ocean.
it fall down?
I hope not.
Okay.
Wow. Okay.
And then Olaf here. We have Olaf. Olaf will be down here.
At the South
Pole.
Hemisphere, South
Yay.
Pole.
And we have one more.
What's this? Oh, we have someone like a penguin, I think. And he has to be here somewhere in the North Pole or close to the Arctic Ocean.
Okay. So these are, just imagine these are objects or beings or even sometimes trees or even buildings on
Yeah.
Earth. So what can you say? When you look at all of these objects on Earth, do they fall down? Down as in downwards? Or do they remain in their positions?
It looks like they are just remaining at their own position.
Yes. Yes, they are. Okay, so that is actually the effect of gravity. Because of gravity, we will not like this choo-choo train will not like fall down.
Oh, no.
Or even Olaf, it will still be there, even though this Earth is like this and it's actually down here, but
It does not fall away from the Earth. Okay.
and they do not float in the air. It will stay grounded. Those are the effects of gravity. Okay, can you repeat that again, Sean?
Okay,
What
so-
are the effects of gravity or gravitational pull on Earth?
Okay, so one of the effects is that objects or people on Earth will remain on Earth. And the second, they would not fly out into the air.
Yay, that is absolutely right. I'm gonna
Yay.
give you 3 stars.
3 stars! And for my friends at home who have also answered the same, hopefully answered the same, and you also get 3 stars. Wow! That's really, really something very interesting that we're going to learn today. But don't go anywhere, because after this, we'll be learning about rotation and revolution. What is that exactly? Well, don't go anywhere. We're back to you for Level 2 on DLP KPM.
Didik TV KPM.
Did you know? Earth's gravitational pull is actually weaker than the pull of a fridge magnet. It ranges between 25,000 and 65,000 nanotesla.
Oh, hi there! You're now watching Level 2 or Tahap on DLP KPM together with me, Sean Stephen, as well as Teacher Nina. Now, earlier at the beginning of our lesson, Teacher Nina showed a video of her dropping an item to the ground, But maybe I don't really believe that, because it has something to do with gravitational pull. So what I'm going to do is, I have this lovely keychain that Miss Nina gave to me, which I want to try and try the experiment for myself. So I'm going to start off here. I'm just going to drop it to the ground. Okay. Oh, okay. It actually fell down.
All right.
You know what? Maybe I'm going to try it over here. Maybe here?
Okay. See what happens.
It still falls down.
Yeah.
How about I toss it to the air? It still
What do
falls
you know?
down. So it looks like what Teacher Nina said was actually correct.
Yes,
yeah.
what Sean did just now proves that gravity is a force that pulls objects to the center of the Earth.
That's true. All right. So let's continue our lesson.
Okay, next we are going to learn about Earth's rotation.
Oh, okay.
What is rotation? Rotation is like spin. The Earth behaves in that way.
Okay.
So for Earth's rotation, there are 3 things that we need to know. Okay.
All right.
The first one would be that the Earth rotates on its axis. What is axis? Do you know, Sean, what is axis? Can you hold the globe?
Here, I'll just go slightly to the back here.
Yeah.
Okay. So here, I just lift it up.
Okay, so what is axis? Can you tell everyone?
I think is this kind of, well, for this object, it's a pole that goes through from the top to the bottom, and I think that is the axis.
Yep. The axis is actually an imaginary line. It doesn't really exist.
Okay. The axis does not exist.
That means if you can go outside from the Earth, you will not see that stick. But what we are saying is that how the Earth rotates is on the axis.
Right.
It will not rotate like this, or it will not rotate like however it will wobble, but it will rotate on its axis. And this axis is not straight, it's tilted a bit.
Oh yes, it's something I noticed. So if it's straight, it should be like this, but it's tilted to a certain degree.
It's tilted a bit. So that is the first imaginary line that we learned today. So the second thing about, you can put it on, Sean.
Yes.
The second thing we learned about rotation is the direction of the rotation.
Yep.
The Earth actually rotates from west to east.
Okay, all right. So that means west is over on this side, east is over on this side?
If north is on this side, so west would be this side. This is west.
Okay.
And this is
yes, this is west. Yeah, okay. All right. Yes.
So the Earth rotates from west to east.
Okay. All right.
Okay.
All right.
And the third one is the duration. How long does it take for the Earth to make one rotation? That means, let's say we start from here. Okay. Let's see from here. And one, cannot not pass through that. Okay. Let's say it makes one rotation and come back to the same place here.
Okay.
It will take 24 hours or 1 day. So one rotation is actually one whole day.
I see. Okay.
So those are the things that you need to remember about rotation. Now let's move on to revolution. Okay. So what is revolution? Revolution is actually another movement made by the Earth. That means the Earth moves two movements at the same time. It rotates and at the same time it revolves around the sun.
Wow, okay.
It revolves around the sun. Okay, Sean, can you please be a sport and be the model for everyone to see?
You want me to be a model? Or you mean to do the spinning?
Okay, let's see. Let's say Sean is the Earth and we have the sun right here. Okay.
Alright.
So how would you rotate? From west to east.
From west towards east, so I'll be rotating this in this direction. So the axis, I'll just imagine that it's in the center of my body, that imaginary line, and I'm spinning on that axis. So like this. This is me. I'm the Earth.
So that is two rotations. Okay. Now at the same time, the Earth will revolve around the sun. That means it will go around the sun.
Okay.
So do you think you can do that?
Of course I can.
Rotate at the same time, revolve. Okay, I'll move a bit here.
Okay,
so Sean.
I'm rotating on my axis. And I am spinning. I am revolving around the sun.
Yes.
Oh wow. Okay. I feel like the real Earth right now. I can see stars.
You can see stars. Okay. What Sean did just now is simulating how the Earth moves.
Yes. Yes. Not an easy task.
Exactly. So that is rotation at the same time revolution. So revolution actually, the Earth moves anti-clockwise.
I see.
Anti-clockwise means if the clock goes this way from 1 o'clock, 2 o'clock, 3 o'clock, anti-clockwise is the other way around. So he moves from west to east in rotation and revolve anti-clockwise.
Wow.
And the duration for Sean to get from that position and make one revolution and come back to the same place, it takes 365 years and 1 quarter.
665
days.
365 days
Yeah,
and a quarter.
365 and a quarter days.
I see. Okay.
What does that 1 quarter means? Okay.
All right.
Okay, let's say Sean starts like this. This Earth is facing this way.
Yep.
And when he makes one revolution, when he comes back to here, add one more, a quarter
A quarter movement, so like
yes.
here.
Yes. This
Okay.
is 1 year. And let's say he moves one more round. The
Okay.
second year, one more quarter, move a bit. This is second year. Third year, and then fourth year. So you see, on the fourth year, there will be 1 extra day. So that is why we have leap year, if you have heard of that.
Because 4 quarters is equivalent to 1.
So that's why we have 29 February.
I see.
Yeah.
Okay, that's it. So an additional day in one of the months in a year, which is on February the 29th.
Yep.
Okay.
So here I have something here, Sean.
Okay.
Maybe you can.
Shall I hold it?
Yes, you can.
Okay.
All right. This is a model of the sun and also the earth, and we have the moon here too. So this is this model is showing how the earth actually look at the earth. Okay. So it will rotate, and at the same time, it will revolve around the sun.
Sure.
Okay, so see?
Wow!
And later you will learn about the moon. Okay, that's just a teaser about the moon.
So
see?
I can see it spinning around. Oh, sorry. Rotating and revolving around the sun.
And see how fast it goes. Okay, so it will make 1 year to make a complete revolution. Okay, so 1 year. So this is 365 1 quarter days.
Okay.
All right, Sean, can we go back here?
Sure.
I have something for you.
Ooh, okay.
Okay, this is actually an activity that we can do. It's a quick one, Sean.
All right.
All right. See, we have a model of the sun. Okay.
Which I have
and
here.
the earth.
Okay.
Okay. And also something to connect them. This is imaginary.
Okay.
Okay. All right. So what we do is we just take one stick. Okay. Poke it into this.
So this can be like a satay stick. I
Yep.
believe. Yep.
And then poke it on the sun.
All right.
Okay.
Through the sun.
Like that. Okay.
All
And
right.
we do the same for the earth.
For the earth as well.
Yep.
So first through the imaginary line. Oh,
Okay.
so mine is a bit blunt. Let me just push that through. Yes, got it through.
Yep.
And we got the earth.
Okay, push
going-
it through.
Oh,
Oops.
sorry about that. So this time double-sided tape is not my friend. Okay, so here.
Okay.
So I have the sun and the earth.
All right. So what we do is we spin the earth.
Okay.
And at the same time we make a revolution. It revolves around the sun. So make sure it is anti-clockwise.
So is this anti-clockwise? Yes.
Okay.
So it spins. Oh, wait. My earth is a bit... Okay, so it spins. It rotates on its own axis. And it revolves around the sun in an anti-clockwise manner.
Yes. Oh my, Sean, I
Yes.
forgot something.
Yes.
About orbit.
Orbit.
Have you heard of the word orbit?
I've heard of it.
Okay, what is orbit? This is concerning revolution. The Earth actually revolve around the sun in an orbit. Orbit is like a path or a lane.
Okay.
Imagine if you're a runner, a 400 meters runner in a
Yes.
stadium on the track.
Okay.
You must stay on your lane, right? So that is like the orbit.
Okay.
And the orbit is also imaginary.
Oh.
If you go up in the sky or in the universe, you will not see that line.
Okay, okay.
But it is there just to show that that is how the Earth will revolve. It
Okay.
will not go off the course.
I
It
see.
will stay there since the beginning of time until the end of time.
Okay. Maybe I can just do an example
Okay.
of it. So I'll just go back again.
All right.
And I'll become the earth and I'll just repeat what you have just said, right? So first, this is the axis. I rotate.
Yes,
on my
rotate.
axis. West to
east.
west to east. So like this.
And then-
And now I'll be revolving around the sun.
Anti-clockwise.
Anti-clockwise, which is this way actually.
Okay.
Okay. We've mistaken.
Yes,
yeah?
okay.
But following an orbit.
Yes.
So imagine I have like a kind of orbit that I can't see, but I'm following it. So here, this is the orbit that I'm following around the sun.
Yes.
So is this correct, Miss Nina?
Yes, that is correct.
All right.
Because what happens if you go off course, if we don't have this orbit,
Yeah.
you might collide with other planets.
Oh no, but because
You
we have
wouldn't want that to
7
happen,
other
right?
planets around the sun,
exactly.
right? But today we're just focusing on Earth.
The Earth, yes.
And so far, what we have learned is in terms of the Earth's rotation on its axis, as well as its revolution around the sun, following its orbit.
Yep.
Very, very interesting indeed. You can also try this at home for those of you who are watching, but warning, you might get a bit dizzy, and that's why we're going to take a short break and be back to you for Level 2 on DLP KPM.
Didik TV KPM.
Did you know? The Earth rotates at the speed of 1,674 kilometers per hour. That is almost 4 times faster than the fastest car in the world.
And we are back for Level 2 Tahap on DLP KPM together with Teacher Nina as well as myself, Sean Stephen, for the topic today where we're learning on the Earth's gravity, rotation and revolution. Let's continue.
Okay, so just now we have learned about Earth's rotation. So now we are going to look at what are the 3 effects of Earth's rotation.
All right.
For the first effect, I need us to be a little bit darker here, please.
Oh, could we have the lights dim in the studio, please?
Okay. So what you have right there in front of you is the globe, which
Yes.
represents the Earth.
Okay.
So we have that Superman over there. Superman is actually standing on Malaysia.
Okay.
And I am going to turn on the light. The light represents the sun.
Okay.
Okay. So can you please rotate the Earth from west to east, Sean?
West to east. So let me just start off here
Okay.
since Superman is standing on Earth. So I'm
Okay.
going to rotate, right? So
All
west to
right,
east.
yes.
It's moving now.
Okay. So stop for a sec.
Yeah.
So what we are actually looking at is the part of the Earth which receives the light from the
Okay.
sun is experiencing daylight.
Okay.
Yeah, so that is the first
So
effect.
over on this side here. Okay.
So this is the day part, and where the Earth does not face the sun is actually having nighttime.
Night. Okay.
Okay. So because the Earth is rotating from west to east,
All right.
we will go to the second effect.
Okay.
Okay. So can you rotate a little bit more?
All right.
Okay.
Rotate.
So now we see that if we are here, let's imagine that everyone is Superman. So you can see that the sun seems as if it rises from the east. Because
Okay.
Earth rotates from west to east.
Okay.
And then as we move, and we will see that the sun will set on the west.
Okay.
Okay. So actually, I have a video.
All right. So we have a video. Let's have a look at that video. Wow, that's a very interesting video indeed. But what's that about?
It shows that the sun appears or seems to be in different positions throughout the day.
Okay.
In the morning, we can see the sun on the east, and then at noon, it will be on the north, and then when it sets in the evening, it will be on our west.
Okay.
So that's the second effect of Earth's rotation. Now we move on to the third effect.
Okay.
I saw something on your shoulder, Sean.
Oh, it's actually Superman that's on my left shoulder.
Okay, so we need to stick Superman here, right here in the middle. Okay, this is actually an investigation. That it is shown actually in the video just now, where we can see the changes in length and also position of the shadow of objects on Earth.
Okay, all right.
Okay, so what we are going to do is we are going to make this Superman as a representation of objects on Earth.
Okay.
Okay, so we will start the investigation now, shall we? All right, so, okay, can we see? Yes, you can see.
Okay, we can see the shadow here.
So, for example, we start with in the morning. Okay, Sean, I need you to be on the board right there because you need to fill in the observation table.
I'll head over there.
Okay, thank you so much, Sean.
Excuse me, pardon.
Okay, so kids, what we are doing right now is we are going to simulate first at 8 a.m. 8 in the morning. So let's see, the sun appears to rise from the east. Okay, let's see. Okay, yes. Can you see the shadow there?
Yes, I can.
So this is the sun.
Okay.
The position. Where is the sun? Is it east, west, north, south?
This should be on the east.
Yes, east. Okay, so write down that 8 a.m. The direction of the sun is on the east.
Okay. So I'll just write east here.
Yep.
E-A-S-T. Is that correct?
Okay.
All right.
So where is the direction of the shadow?
So it's pointing towards the west?
Yes, you are right.
Okay. West.
Okay. So now I am going to measure the length of the shadow at 8 a.m. It's about, right there, 10 centimeters.
10 centimeters.
10 centimeters, yes.
Okay.
All right.
Got it.
Okay, got it. Now, we move on to the second one is 10:30 a.m.
All right.
Okay, so for 10:30 a.m., the sun will be a little bit higher up. But it is still in the...
It's still in the east?
East, yes, very good. East.
Okay.
Okay. So where is the shadow?
Where is the shadow? I think my friends who are also watching right now can somehow guess if the direction of the sun is in the east. Where is the direction of the shadow? What do you think? That's right. It is on the west.
West.
Oh, facing the west.
Yes. Okay, now I am going to measure the length of the shadow. Now it is only 6 centimeters.
Okay.
Okay.
6 centimeters.
Just now it was 10 centimeters. All right, now 1 p.m. 1 p.m. would be, in Peninsular Malaysia, it would be right on top. Okay. So the sun is right above our head. So where is this position of the sun?
The position of the sun is above would mean, what do you think? It's I think it's on the at the north.
Yes, you are right. North.
North. Okay. N-O-R-T-H.
Yes, very good. Okay, what about the direction of the shadow?
Direction of the shadow? If it's right above us,
so the shadow is?
Shadow is just below us, so south?
Yes, you are right. South.
South.
Very good, Sean. Okay, now I'm going to measure. Can I actually measure it? Because
it looks like it's very small.
Yeah, it's less than 1 centimeter. Less than 1. You can put there 0.5.
0.5 centimeters.
0.5 centimeters.
All right.
Okay, so you saw from morning 8 a.m. the sun was here, and then it moves up here to the northern part, and then now it's 3:30 p.m.
All right.
Where is the sun now?
Now the sun is the west.
West, yes.
W-E-S-T, west.
Okay, and what about the shadow now? Where is it?
Can you guess?
Oh.
That's right. It is now facing the east.
Yes, you are right.
Facing east. E-A-S-T.
Okay, now I am going to measure. Oh, it's 6.
6
6 centimeters. Yes, 6 centimeters.
Okay, 6 centimeters.
Okay. And then we move on until late in the evening at around 6 p.m.
Okay.
6 in the evening. So, where is the sun now?
The sun looks like, what did you say? Yes. Looks like it's still in the west.
Yes, and it's about to set now.
Oh.
Okay, and what about the direction of the shadow?
I believe it is still facing east.
Yes.
Okay, let me just write that.
that's right.
Apologies for my handwriting.
It's okay, that makes you you. Okay, now I'm going to measure. It is about 9.5 10. Make it 10.
10 centimeters.
10 centimeters. The length of the shadow. Okay, so there we have it. Can we have now make a conclusion based on what we have there?
Okay.
Okay, so what can you say about the direction of the sun? It appears that the sun rises from the east, and sets to the west.
The west.
Okay, what about the direction of the shadow?
The shadow, however, is somewhat the opposite.
Yes, you are right. Okay, so the direction of the shadow is the opposite of the direction of sun.
All right. So how many points do I get from this?
Okay. How many stars do you want?
I want 20.
I'll give you 4 stars, Sean.
Wow, 4 stars. Thank you so
big
much.
stars. That's even more than that 20 small ones. Okay,
Great,
now the
yeah.
most important part is the length of the shadow.
Okay.
Look at the numbers carefully.
Okay.
From 10 to 6 to 0.5 and then to 6 to 10. What can you say about the trend? Is it increasing or decreasing or both? How would you say?
It looks like it decreases from 8 a.m. to 1 p.m. And then it increases back when it hits towards 6 p.m.
Yes, you are right. That is so observant of you. That is absolutely right. So the length of shadow decreases and then increases from morning until evening.
Yay!
So those are the effects of the rotation of the earth.
Okay.
So because the earth rotates, so we can see that the sun is, sometimes you can see it on the east and then north and then west, and the shadow.
Yes.
The shadow of objects on earth also will change in terms of the direction of the shadow and also the length of the shadow.
Yes,
so you can see early in the morning you'll have a longer shadow, and also late in the evening too. Towards afternoon, it will be very short. Your shadow will be very, very short.
I see. And also what I've noticed from what you have mentioned, Teacher Dina, is that, for example, at 8 a.m. or before 8 a.m. we get to see the sunrise.
Yes.
Okay? So because of the rotation of the earth, the place where the sun rises and sets are 2 different places.
Yes, exactly.
So that would mean I would maybe if I'm in my room and I have a window, I may be able to see the sunrise, but because if I'm seeing the sunrise over here, that would mean the sun would set somewhere behind me.
Yes, exactly.
If I do not have a window, I won't be able to see it.
Yes, that is why. You're right. Okay. So Sean,
Yes?
I want you to repeat back. What are the 3 effects of the Earth's rotation?
Okay, 3 effects of the Earth's rotation. Number 1, the occurrence of day and night. Number 2, what you can see is the sun would somehow seem that it's rising from the east and setting in the west.
Okay.
And third would be the length of shadow, depending on where we're standing. Obviously, it will look like it's pointing towards the west from the start of the day. Is that right? Yes. And at the end of the day, it looks like it's pointing towards the east.
Or you can easily say that it is opposite the direction of the sun. Yeah, you are absolutely right. So I'm going to give you extra 3 stars, Sean. Woohoo!
Thank you so much, Teacher Nina.
Okay.
And for those of you who also watch at home, hopefully you got your answers correct as well. And just to repeat again, the occurrence of day and night, the sun seems to change its position as well as changes in the length and direction of shadow. And of course, for our friends who's watching right now at home, I believe we have somewhat of a homework for them.
Yes, homework time. Okay, we have learned so much today about the rotation, revolution, and also gravity. Why don't you try and make a poster of it?
Ooh.
Whatever you have understood, you can make maybe slides if you like to use digital posters, or you can make normal posters to show that you really understand what is rotation.
Yeah.
How long does it take for the Earth to rotate? And what about revolution? What is revolution? And the most important part, what we just learned just now, is about the effects of Earth's rotation on its axis.
Yes, that's right. So that's the homework that you have, just before ending the show. But of course, we're not going to end just yet. We're going to continue right after this, and we're going to test whether or not you understand or paid attention to our lesson for today. So don't go anywhere. We'll be back to you for Level 2 on DLP KPM.
Didik TV KPM.
Did you know? Some parts of Earth experience 24 hours daytime, midnight sun, and 24 hours nighttime, polar night, because of the Earth revolution.
We are back for Level 2 on Didik TV KPM together with me, Sean, Stephen, and also our wonderful teacher, Nina, in the classroom today. Now, just before break, we have learned so much in terms of the gravity, in terms of rotation, as well as revolution. All right, so let's continue.
Okay, for the last segment now, what we are going to do is we are going to test Sean.
Oh!
Does Sean remember everything that we have learned since the beginning of this show?
I hope so.
Let's start with the first one.
Okay.
It's about the gravitational pull on Earth, or simply known as gravity.
Okay.
What is gravity, Sean? Remember, you did the activity just now? You played with the keychain that I gave you?
Okay. I think my friends at home can also answer this question, where gravity is a force that pulls objects to the center of the Earth. Let me write that down.
Correct. Okay, write it down.
Force.
Okay. All right, everyone, please don't judge Sean based on his handwriting. When was the last time you write on the board, Sean?
It's been a while. To the center of the Earth.
Okay, can you repeat again what you have written?
Gravity is a force that pulls objects to the center of the Earth.
Okay, towards the center of the Earth. You are right, Sean.
Yay!
Very good. Okay, so we have learned what is gravity. So what are the effects of gravity? There are 2 effects. If you remember, we played with things, we put it on this globe and it doesn't fall down on the counter. So what can we say?
Alright, so let me try and see what I can answer correctly. Hopefully my friends can answer as well. The 2 effects. The first would be objects or people would remain on Earth. And
remain.
the second would so that they won't float in the air or fly off from planet Earth.
Remain on Earth or remain where?
Remain on Earth.
Remain
On the ground.
in their...
In their current position.
Yes, in their position. Very good.
Okay, so I'm just going to put it in point form, right?
Objects remain.
Objects remain on current position.
On its position, on their position.
Okay.
number
no,
two.
my handwriting is really okay.
It's okay.
And
All
two
right.
is that so that they don't float in the air.
Yes.
So I'll just put a X float, just because
That
we would like to
is-
save time. In
That is
the
a short form, but if you have to write it in your book, please
okay,
write
so you know what?
in.
I'll probably write it properly.
Okay.
Oh no, I think I made it worse. But yes, this says don't float in the air.
Yes,
Or
you do
won't
not
float
float
in the air.
Okay, that's very good. Now we move on to Earth's rotation on its. I'm not going to say the word.
Okay.
Okay, so what is the imaginary line right there, Sean?
This one over here?
Yes.
All right. So
what
I
do we
think
call that?
everyone would know this already when seeing me spinning or rotating on my axis. Well,
You said it.
Yeah, there's an answer
You
here.
said it.
Yes,
Okay.
an axis.
Is
So let
it
me just take this
right?
out.
Yay!
Yay.
Very good. So what is the direction of the
Direction.
rotation?
I rotated this way, so from the west to the east.
Let's see if it's correct.
Let's see.
You are
Yeah.
right. And okay, what about the duration? How long
Duration.
does it take to make one full rotation?
So one full rotation will take 1 day or 24 hours.
Yes, is it correct?
Yay!
You are right.
I'm on a
Very
roll.
good. Okay.
Okay.
Next one is the Earth's revolution around the sun.
Okay.
So what is the name of the path there, the lane where the Earth revolves around the sun? What do we call that
This one?
imaginary line?
Oh, I think it's called an orbit.
Is it right?
Yeah.
You are absolutely right. So the direction?
Direction, if
How
it's
does it
moving
revolve?
this way, would be anti-clockwise.
Yes, anti-clockwise, the opposite of the clock direction.
Okay.
Yep. And duration, how long does it take to make one revolution
One
around the
revolution
sun?
would be 1 year, or more specifically, 365 and a quarter days.
Is it true? Is it true? Is it true?
Okay.
Woohoo!
Yeah.
You are absolutely right, Sean. Yay! Okay.
And because of that, I think you want me to answer the final one, which is effects of Earth's rotation on its axis.
Okay.
I'm just going to do a quick one just to
Okay.
save some time, which is 3, the occurrence of day and night.
Okay, yes.
The sun looks like it's rises from the east and sets in the west, and also the direction of the shadow seems to be the opposite of the rising and setting of the sun.
What about the length of the shadow?
The length of the shadow will increase and decrease from morning till evening. Sorry,
Again,
the other way.
again?
Will decrease and then increase from morning till evening.
Yes, you are absolutely right. Okay,
Yes.
since Sean didn't write his answers, why don't you try and write your answers in your notebook, your science notebook, and show it to your teacher, and your teacher will give you 5 stars for that.
Yeah.
Do you like that?
Do I get 5 stars for this?
Yes. Wait. Let us check our learning outcomes. Have you reached everything? Have you achieved everything? Okay.
Okay.
You have described the gravitational pull on Earth. Yes. You have made the generalization that all objects on Earth remain in their position.
Yeah.
Okay. Yes. You have stated that the Earth rotates on its axis. And at the same time, it revolves around the sun. Okay, yes, you did that. And also, you have described just now the 3 things that you need to remember about rotation and also revolution. Okay, in terms of direction and duration, you did that. And also, last but not least, you have described the effects of rotation of the Earth on its axis. So, as a reward, you
Yes.
will get full 6 stars.
6 stars!
Yay!
Wow! Thank you so much, Teacher Nina.
Congratulations, Sean.
I couldn't have done it without you. Thank you so much, Teacher Nina, for all the sharing of information and also your lesson today. But for those of you watching at home, how can they get extra exercise? Is there any platform that they can get that to further
of
enhance
course.
their understanding?
For you to get all the notes and also exercises, you can go to Sumberku.
All right, so there you have it. Thank you once again, Teacher Nina, for our lesson for today. And thank you for watching our lesson, which is on Level 2 on DLP KPM. And we'll see you in our next lesson right here on DLP KPM. Till then, stay safe. Bye.
Bye. Sean, come.
Oh, let's go. Oh.
TV KPM.